So, we are learning about different approaches to solve multi-objective optimization problem. In the last few lectures, we have learned different approaches belong to non-Pareto based and Pareto based approach. We will continue our discussion. Today, we will learn few more Pareto based approaches. So, first we learn about the most popular one compared to the other Pareto based approach. It is called non-dominated sorting genetic algorithm. Shortly, it is termed as NSGA. So, today we learn about this the technique, the NSGA algorithm. This algorithm first time proposed by N. Srinivas and K. Dev in 1994. They have published this work in the journal called IEEE Transactions on Evolutionary Computing, and the title of the paper was Multi-Objective Optimization Using Non-Dominated Sorting in Genetic Algorithm. Now, this algorithm is different from the previous algorithm in the in terms of the concept that they followed. So, it basically based on the concepts of non-dominated sorting procedure, and then they used another method, another concept, it is called the niched method. So, they basically select the non-dominated front by means of non-dominated sorting techniques. It is basically a ranking based selection method to select the good solutions which are to be in the non-dominated fonts, and then in order to have a good population diversity and then better selection pressure, they follow while they assign the fitness value to the solutions, and they follow one concept, it is called the niched sharing. So, we will discuss about the two concepts, and then we will know exactly how NSGA the algorithm works. Now, in order to understand the algorithm, we will consider few terminologies. So, suppose P denotes a set of input solutions. Basically, given the input solution, it is basically the current population we can say. So, we have to find for the current population all the solutions which are lying on the non-dominated font. So, P is the current solution. P is the current solution. So, P denotes the current solution, and xi denotes any ith solution in the current set. So, xi is a solution which belongs to the set P. We denote Si is a set of solutions, is a basically subset of P which basically contains all the solutions which dominate the solution xi. So, Si contains all the solution which dominates xi, and then Ni denotes the domination count. It basically defines the number of solutions which dominates xi, and we also denotes another notation called the Pk denotes a non-domination front at the kth level. Anyway, so we can explain all this terminology in with an example, so that we can understand about the concept. Let us follow this diagram. In this diagram, so this basically denotes all the solutions. We say this is the P is the set of all solutions, and then we consider any solution xi. So, if xi, and in this case we consider that f1 is a function to be maximized and f2 function to be maximized, both the function to be maximized. If so, then this xi is the solution, and then in this case the Si which denotes the solution which dominate Xi. So, in this case these are the solution. So, these are the basically solution. Okay, if this is the solution, then these are the solution basically called Si. These are the solutions which dominates this one, and then we define the domination count Ni. So, basically by which all the solutions is basically this solution dominates all other solution in this region. So, the number of solution in this is basically Ni, the solution count of Xi, and the front. So, this is the solution which is basically the non-dominated solution, because there is no solution which is dominated by this. So, these are the solution is a non-dominated solution, and it basically creates a front. We can say this front is 1. So, it is basically this is the front P1, the first front. Now, if we remove all the solution from this front, then it will give another front, the next front. If we remove all these solutions from here, then the next front is basically next non-dominated front or next front, and similarly if we remove all these solution, then next front and next front. So, these are the different fronts. So, front 1, front 2, front 3, front 4, like this one. So, these are the concept that is there. So, we have learned about the different terminologies. Now, let us see how the algorithm can be defined here and what is the procedure there in the algorithm. Now, so the algorithm basically find the non-dominated front and then the other dominated other fronts. So, let us see how this algorithm works. So, here this is the code that we have given it here. This code is basically to find the the non-dominated front, that means outermost front, and here basically for each solution Xi which is in the set P, and for all other solution Xj such that it is not equals to the Xi and this Xj belongs to P, then we will consider this one. If Xi dominates Xj, then we put Xj into the set Si. So, Si is basically the solution which basically dominated by X. So, it is basically if Xi dominates Xj, then it is included in the solution Si, and if it is not dominated, so it is there, that means if Xj dominates Xi, then we can count the domination count. So, Ni equals to Ni plus 1. So, this way it basically count the solution domination count as well as the solutions the dominated sets, and obviously if Ni equals to 0 for all the fonts that is there, then we can say these solutions Si is basically the P1, that is mean the first front, and we can say k equals to 1. So, this basically the front, and it is called the first front or non-dominated sorting front, the first non-dominated sorting front. And then we can find in the same way the other fronts. So, here the procedure. So, it is basically initially say the kth front. So, Pk initially it is 5, because initially there is no element in the front. Then we, if we repeat these steps, then it will create the front Pk. So, so for each solution Xi in Pk, Pk is basically the first, it will start from the first front P1, and for each solution Xj in Si we have to do this one, and then we can add into the Q. So, finally, Q will give the next front after the Pk front. So, this way we can find all the solutions, all the other fronts in the set of solutions. So, this way we can find, it is a little bit a programming approach, we can find using the concept of domination the first front, second front, and then nth front depending on the number of solutions are there. Now, so these programs, I have mentioned this program in order to understand that how much time that it will take. So, it can be observed that the time complexity of this procedure of finding non-dominated sorting fronts, or it is basically called the non-dominated sorting procedure, the time complexity of this procedure can be seen as order of m into n square, where m is the number of objectives and n is the size of the population. So, it is basically in terms of this complexity, and regarding this complexity we will discuss few more things later on. So, this is the procedure. The non-dominated sorting procedure is the main one critical procedure. It is there in the NSGA algorithm. Now, again I can illustrate this concept. Let us consider these are the solutions set here, these are the solution sets here, and here f1 is maximized and f2 is minimized. So, if it is like this, then we can easily understand that. So, these are the solution which are basically the first front, you can easily identify, and then this is the solution which is the second front, and this is the solution which is in the third front. So, in this concept there are three fronts, as you can say, and the three fronts are like this. Three fronts are like this, and so here we can say that the solution in the front 3, 5 are the best solution, and they are basically called the non-dominated solution. On the other hand, this solution 1 by 4 the next inferior solution, and finally the solution 2 are the worst solution so far the front is concerned. So, these are the different fronts and the different solutions are there. Now, if we order all the solution based on their this front, then we can say these are the ordering. So, this is the first front, second front, next front, and so on, so on. So, this ordering is called non-dominated ordering, right. So, what I want to emphasize is that given a set of solution, we shall be able to find using the non-dominated sorting procedure the different fronts and ordering of the different fronts. And so far the ordering is concerned, we can say all the solution which belongs to this front can be termed as rank 1, and this is the solution rank 2 and rank 3. So, non-dominated sorting procedure allow us to find the rank of all the solutions given a set of solution or current solution set. So, this is the one important concept that is fundamental there in case of non-dominated sorting generating algorithm. And then we will discuss about the basic techniques which is followed there in NSGA algorithm. So, first we have already mentioned that it basically based on the classification of several front that can be there in the set of solution, and it finds, in fact it finds a front at particular rank, and then basically assign a fitness value. So, we will discuss about these are the concept that okay, we know exactly how to decide a rank of the solution. This basically deciding the rank of the solution by virtue of following the non-dominated sorting techniques. Once the rank is known to us, then we shall be able to assign a fitness value. So, this is one important task that is followed there. This fitness value is also called dummy fitness value to each solution in the front, and then the next technique that it follows is basically sharing of fitness values. So, now our task is to understand how to assign a fitness value, that is the dummy fitness value to each solution, and then how to share the fitness value, and what is the rationale behind these things also we shall be able to learn. So, basically once this fitness value is assigned and sharing a fitness value, this means that each solution will be given a fitness value as per the NSGA technique. Once the fitness value is assigned to each solution, then it basically consider the solution based on their fitness value to be considered in the mating pool, and then they will be considered for the reproduction. Here the reproduction procedure is same as the genetic algorithm. So, basic idea is that we have to create the mating pool, and for this mating pool creation, this is the selection strategy that it follows. And selection strategy means it basically find the non-dominated front, and then followed by the assigning dummy fitness value, and then finally the sharing fitness value. So, this basically gives the fitness calculation to all the solutions, and based on the fitness calculation we shall follow the reproduction. Now, so this diagram shows the flowchart of the algorithm. Now, if we little bit carefully check it, so it is basically start with the initial population and then it will basically consider the classification of the font and then sharing of the fitness value, assigning dummy fitness value. This is the step it is there. Now, here basically start with the first font k equals to 1 and then identify so k equals to 1. So, basically it consider the first font then because the kth font and then assign dummy fitness value and dummy fitness sharing. So, this basically for the kth font. So, k starting with 1 and this will procedure for all the solution until all the solutions are assigned the fitness value and sharing this one. Once all the solutions are assigned some fitness value, then it will come here. This is basically selection of matching pool. The selection can be the same selection that is there in GA technique like Rowlett wheel selection. Once the mating pool is selected, then the reproduction procedure and then evaluation of the solutions, and if we check the convergence criteria reached or not, if reached, this is the solution that can be obtained here, otherwise it will repeat the procedure for the next generation. So, the idea it is like this, and so basically if we see this is the conventional GA framework, whereas this basically the idea about how the selection techniques is different than the conventional GA technique. So, this is the flowchart of the algorithm NSGA. So, there are main two tasks, classification and sharing, and then we will discuss about the sharing concept, how the sharing is there, and then sharing is basically use the dummy fitness value assignment. Now, let us see how the sharing and dummy fitness value assignment is there in the NSGA 2. So, here the basic idea about assigning dummy fitness values is basically we first find all the fronts, then assign dummy fitness value to each solution belongs to a particular front. So, here basically the idea it is that dummy fitness value is a very large number and typically it is proportional to the number of population which includes the number of individual in all front including the current front. Now, here is the idea it is there at any instant if this is the one solution we have to assign a dummy fitness value, it basically assign one number which is very large number, the number is denoted by all the solution which is in other which is not in the which is in this front as well as all the fronts below this front. So, it is the concept. So, all the solutions and then plus all the solution in this front include this is the large number of values are there and this assign. So, it is again you can see all the solution which is there in the front is basically assigned the same dummy fitness value. So, this way we can assign the dummy fitness value and it is a proportional number, sometime proportional constant will be greater than 1 to have a very good number. So, this basically assign the dummy fitness values to all the solution, and you can say that if we assign the dummy fitness value to the non-dominated front, that means the first front they have the very higher number, then the next front and so on so on. As the front goes higher, the dummy fitness value assign goes lower. So, this way we can basically give the fitness values the tentative fitness values now. So, that can be very large and for the best solution, for the superior solution has the large number of what is called the dummy fitness values compared to the inferior solution to that. So, this basically assigning the dummy fitness values. So, here actually we can summarize the things that is there. The same fitness value is assigned to give an equal reproductive potential to all the individuals belong to a front. A higher value is assigned to individuals in an upper layer front to ensure selection pressure, that is having better chance to be selected for mating. And as we go from an upper front to the next lower front, count of individuals are ignored, that is logically removed from the population set, and thus number of population successively decreases as we move from one front to the next front. Okay, so, this is the idea about dummy fitness values assignment, and our next concept there in the NSGA is sharing the fitness value. So, here basically we have understood that assigning dummy fitness value, the main purpose is to have a very good selection pressure. And then the sharing the fitness value is the objective is to that how the population diversity can be there, so that we can find better solution and the solution cannot be tapped into the local optima. So here the idea about sharing the fitness value is like this. So in any front, all individuals are assigned with a dummy fitness value which is proportional number of population. These individuals are then shared with their dummy fitness values. So it is called the sharing concept. Now sharing is divided, sharing is achieved by dividing the dummy fitness value by a quantity proportional to the number of individuals around it. Now this is the one concept. It is basically the niche concept. So it is niche count. So here the idea is that if, so this is the one solution and it on one font, and we have already assigned one dummy fitness values. So we have to we have to share the fitness value in the sense that now we have to see what are the solutions which is around this one, right. So if this is the solution which has the less solution around this one, then it has less niche count than this one. So dummy fitness value that has been assigned to this solution, if we divide it by this niche count, then it is called the shared fitness value. So the solutions which has very large niche count have the higher fitness value, and compared to the solution which has less niche count has the less shared fitness value. So this way all the solutions when assigned the dummy fitness value in a particular front have the same dummy fitness values. After the sharing information, they even all the solutions in the same front have the different fitness values, and that is the ultimate fitness value that should be considered in the mating pool selection procedure. So this is the idea about the concept niche count. Now so niche count, how this niche count can be considered, can be calculated. The idea, it is the same idea once we have discussed about sharing the niche values in the NSGA algorithm. It is the same concept, it is followed there in NSGA. So here basically we say Dij is basically the distance between two solution xi and xj, and again another constant that needs to be decided, it is called the T shared. So it is basically if this is the solution xi and T shared is denote that how far we have to consider, that means what will be the region of sharing basically. So it is xi and this is the radius, it is called the T shared. Then whichever the solution which is there, it will be considered the shared dj count sdj, and it is the formula this one. So this is the same formula we have used there in NPJ algorithm. So finally for this solution and then for all other solution within this region, it will calculate SHDij, and then SHDij is basically the sharing information, or it is basically the niche count. So these are the niche count. Now SHDij it is higher if we find the number of solutions higher, and it is lower if the number of solution this one. So it is basically niche count. That means it is basically how a solution is in a region which is basically having the higher population density compared to the others. So the solution which has the higher population density has the higher value of niche count compared to the solution with the less population density. Now so here basically the concept of how to niche count for each solutions that can be obtained. Once this solution is there, then we will be able to consider about okay. So this basically the total niche count if we consider all solutions with respect to the ith solution belongs to a particular font pk, and then we can share the fitness value if f is the original signal value of the ith solution and divided by the gamma xi, that is the niche count of the solution, it is there. Now you can understand that the solution which has the lower population density has the fitness value is this one, higher fitness value, and which has the niche count higher, it has the lower value. Now it is little bit confusing, like actually it is the idea is that sometimes the good solution should be combined with the bad solutions, this because the population diversity is much more. So if we consider all good solution, then population diversity is less. So we have to share the fitness value so that the fitness value can be shared among the little bit solutions which are not so good solution or inferior. So, share count is basically says that how a solution can be a good representative, then the other solutions are there. So, this way we will be able to find that this one. So, this basically the shared fitness value, and these are the final values that needs to be considered for all solutions before the mating pool creation. Now, so the idea it is like this. Okay, we have discussed about, so this solution and this solution, if this is this one, it has the niche count is much more, then this solution has the niche count less. So, we will select, we will prefer for the mating pool compared to if they are competitor, then we will prefer this solution than this one. Although all solutions have the same dummy fitness value, but whenever divided by this share niche count, it gets more weightage than this one. So, this way we will be able to maintain the population diversity. So, this way you can learn about how the solutions particularly belongs to a particular front can be shared, and then we can consider for mating pool creation. Now, so once it is there, then we have to go for the selection procedure for the mating pool creation. So, all the solutions on the particular front, we have to follow one method called the stochastic remainder proportionate selection technique, which is discussed here. It is basically essentially a roulette wheel selections technique, and generates basically a random number Ri, and then follows the random number to consider the same procedure as roulette wheel in a cumulative probabilities concept that can be considered, and it can be used to select the solution there. So, this basically the same procedure that is there in the roulette wheel selection, and but here the one difference is that in this method is basically it calculates based on this Ri and selection of the particular jth solution, it calculates the expected count. We have learned about the expected count while we are discussing about roulette wheel selection method, and then it basically okay, in the previous roulette wheel method that we have learned, then we have to generate the random number each time, but it does not require to random number in this procedure. It basically follow the calculation of Ej, which is using this formula, and then if Ej is non-zero, then the solution is selected, and then for remaining, that means for the in non-integer parts we can use non-integer 1.2568. So, it is basically this is the next random number to be considered if it is there. So, this is the procedure it is followed. Instead of generating random number, it will follow this concept, so that we can avoid the computational hassles there. So, this way the selection can be done, and then mating can be procedure, and the reproduction procedure same as the reproduction procedure there in the simple genetic algorithm. Now, I just want to conclude before going to stop this discussion. Here the it has been observed that if we compare the NSGA technique with respect to MOGA and NPGA, it is observed that in most of the cases NSGA gives better result compared to the MOGA and NPGA. However, the main drawbacks of the NSGA is that this algorithm compared to the MOGA and NPGA is computationally expensive. It has been observed that a computational time that is required for this is order of mn cube if we consider the entire procedures there. So, other than this inefficiency so far the timing or the time that is required to compute this algorithm is concerned, there is another is that this algorithm should consider one parameter to be decided by the programmer T share in order to niche count. So, these are the two serious drawbacks that is there in this NSGA, and another approach is that this is basically non-elitism approach, because it gives a favor to sometimes the inferior solution also, because the non-dominated front is basically or the front we have considered, they are basically the non-elitism approach. So, these are the three criticism against the NSGA, and then the same author who proposed NSGA, they have proposed another version of the NSGA, it is called the NSGA2 algorithm. So, we will discuss this NSGA2 algorithm in the next lecture. Thank you.